Hi there. In this video, we are going to be talking about biconditional statements and how to recognize good definitions. So first of all, a biconditional is a single true statement that combines a true conditional and its true converse. And it's combined by using the words if and only if. Let me get a pen here. If and only if. And we shorten that oftentimes by writing IFF between the two. So a biconditional combines this. So if P, then Q, if that's true, and if Q, then P is true, then you can write it as P if and only if Q is true. Okay, so let me show you with an example. I think that'll make a little more sense. So if two lines intersect at right angles, so in other words, you have these two lines, and they intersect to make 90 degrees, all of these are 90 degrees, then they are perpendicular. Well, that's a true statement. So this is it's an if-then. This is the A part, this is the B part. Now notice the converse. It says if two lines are perpendicular, that's the B part, then they intersect at right angles, that's the A part. So if two lines are perpendicular, then they intersect at right angles. Yep, they do intersect at right angles. So that is also true. So the conditional and the converse are true. So you can write it as one statement. And here's what you do. You get rid of the if, you get rid of the then, and you connect either A or B, whichever you want to put first, it doesn't matter, with if and only if in the middle. So two lines are perpendicular if and only if they intersect at right angles. Now again, because it's true both ways, you could have switched this part and this part. You could have said if two lines intersect at right angle, or excuse me, two lines intersect at right angles if and only if they are perpendicular. It can be written either way. So to write a biconditional, you drop the if, you drop the then, and you put if and only if in the middle, and you can write IFF instead of writing all the words. Okay, so what is the converse of the following true conditionals? If the converses are also true, write the statements as biconditionals. So this one says, if the sum of the measures of two angles is 180, then the two angles are supplementary. Well, is that true? Yep, if the sum is 180, then they're supplementary, so that would be true. Okay, that's a conditional. It's an if-then. Now we'll do the converse. So if two angles are supplementary, then the sum of the measures, of the angles is 180. Okay, so let's look at that and see if it's true. If two angles are supplementary, then the sum of the measures is 180. That's also true. So we can write that as a biconditional since it's true both ways. So what we're going to do is we're going to take the first statement. We're going to get rid of the if, we're going to get rid of the then, and we're going to put if and only if in the middle. So we'll write the sum of the measures of two angles is 180 if and only if. So we'll put IFF, the two angles are supplementary. And that's it. That's your biconditional. All right, let's do another one. If two angles have equal measure, then the angles are congruent. Well, it's true. If they have equal measure, then they're congruent. True. Let's do the converse. So we will flip the A and the B. So if two angles are congruent, then they have equal measure. Equal measures. That should be measures right here. That's a typo. All right, if two angles are congruent, then they have equal measures. That's also true, which means we can write it as a biconditional. And it doesn't matter which one we choose. This time, I'll take the converse. Get rid of the if, get rid of the then, and we're going to put if and only if in the middle. Two angles are congruent and you know what? When you have a word like this, to shorten our writing, you can just put the symbol in there like that. Remember, that means congruent. You have the little squiggle line on top of the equal. If and only if they have equal measure. Equal measures. Okay, there we go. There's our biconditional. Two angles are congruent if and only if they have equal measures. All right, so what are the two conditional statements that form this biconditional? So now we're going to go the other direction. If and only if is in the middle. So it means it's true both ways. So to write the two, we're going to say if a ray is an angle bisector, then it divides an angle into two congruent angles. Congruent and angles, we're going to do this. We're going to even write angles like that just to shorten our writing. Use some math symbols in there. And we have to write it the other way because it says what are the two conditional statements. So which means we're going to switch the A and the B part around. So if a segment, it would be, or excuse me, if a ray divides, so it refers to the ray. So if a ray divides an angle into two congruent angles, then it is an angle bisector. So this is the A part and the B part. So here we went if A, then B. Here we went if B, then A. So that's how we do that. The next one says two numbers are reciprocals if and only if their product is 1. So remember a reciprocal, like if you have 2/3, the reciprocal would be 3/2. And if you multiply those together, you get 6/6, which equals 1. So that's a true statement. So to write this as two conditional statements, we add if two numbers are reciprocals, then their product is 1. That's the A part, that's the B part. Now the second one would be the converse. So we switch the A and the B part. So if, whoops, If the product of two numbers is 1, because what is they're talking about is talking about those two numbers, then the numbers, or the two numbers, are reciprocals. Okay, so that's how you do that. Now, a good definition, let's talk about that. It's a statement that can help you identify or classify an object. It has the following components. It has clearly understood terms. It's precise, which means you avoid words like large or sort of or almost, because like if you're talking about an elephant, it wouldn't be a good definition to say an elephant is a large animal. Because large in reference to what? Because if you're thinking about like a cat could be large if you were comparing it to an ant, for example. So, so we definitely want to clarify. We don't want to use a word like large, okay? Because it's like large compared to what, or sort of, or almost. Don't use words like that. Also, a good definition is reversible. In other words, it can be written as a true biconditional, which means it's true either way if you reverse it. So let's look at some examples here. Are these definitions reversible? And if yes, write each as a true biconditional. So a quadrilateral is a polygon with 4 sides. So we're going to decide if it's true. First of all, a quadrilateral is a polygon with 4 sides. That is true. Can you reverse it? So can you say a polygon with 4 sides is a quadrilateral? Yes, a polygon with 4 sides, okay, it's a quadrilateral. So what we could do then is we could say a quadrilateral is let me think about this. A quadrilateral is a polygon if and only if it has 4 sides. If and only if it has 4 sides. All right, the next one. A straight angle is an angle that measures 180. All right, that's true. So if we switch that around and said an angle that measures 180 is a straight angle, is that true? It is also true. So to write that, I might have to change the wording a little bit. So a straight angle is an angle. We wouldn't say if and only if, because it is a straight angle is an angle, but we would say an angle is a straight angle if and only if it measures 180. An angle is a straight angle if and only if it measures 180, and that should be degrees. All right, so that's how we do that. We add if and only if in the middle there. All right, one way to show that a statement is not a good definition is to use a counter example. So, which of the following is a good definition? Let's look at these. A fish is an animal that swims. Is that a good definition of a fish? Because remember, a good definition, we could say it, we could write the converse and it would be also true. So if we said an animal that swims is a fish, is that true written that way? Well, not necessarily always, because other animals swim. Like I just heard about deer that swim. So that is false. That's a bad one. Or I shouldn't write false. I should just write it's not a good definition. Okay, let's look at the next one. Giraffes are animals with very long necks. Well, is it true both ways? Animals with very long necks are giraffes? No, I bet all of you could think of an animal that has a long neck that's not necessarily a giraffe. So that's not a good definition. How about rectangles have 4 corners? Well, shapes that have 4 corners are rectangles. Can you have other shapes that have 4 corners that are rectangles? Well, how about a diamond? That's not necessarily a rectangle. That doesn't have right angles in the corner, right? So that's not good. It's not reversible. And a counterexample would be by giving a diamond. A counterexample here would be giving a name of another animal that swims like a deer. So a penny is a coin worth 1 cent. Can you reverse it? A coin worth 1 cent is a penny. That's true. Yes, so that you can't give a counterexample to a coin that's worth 1 cent in our money system. Okay, how can you write the following statement as 2 true conditionals? So collinear points are points that lie on the same line. So collinear points are points that lie on the same line. So let's remember what a conditional is. A conditional is an if, then. So if points are collinear, then they lie on the same line. If points are collinear, then they lie on the same line. All right, and then the other one would be if we wrote the converse, okay? So we would say if points lie on the same line, then they are collinear. So instead of writing that out, that's how we would do it. I'll just tell you. So if points lie on the same line, then they are collinear. And the next one says, how can you combine the following statements as a biconditional? If this month is June, then next month is July. If next month is July, then this month is June. So think about it. First of all, are they true? If this month is June, next month is July? Yep. If next month is July, then this month is June. True. So again, how can you combine it? Well, you could do it 2 different ways. You could cross out the if, cross out the then, and put if and only if there. Or you could do it to this one and write if and only if. So next month is July, if and only if this month is June. And then you would write for this one, this month is June, if and only if next month is July. So those are the 2 possible answers. You only have to give one of those answers. All right, next one. Why is the following statement a poor definition? Elephants are gigantic animals. Well, there are other animals that are gigantic, so you would want to give a more specific description. So this is not specific enough. Okay, and then the next one, which of the statements is a better definition of a linear pair? So remember, a linear pair would be angles that up to 180. So a linear pair is a pair of supplementary angles. Or the other one is a linear pair is a pair of adjacent angles with the non-common sides that are opposite rays. Well, you want to think about this, and you can maybe give some counter examples to help you figure out which is the better. So a linear pair, it is true they're supplementary angles. However, you remember we can have supplementary angles. These 2 add up to 180, but they're not a linear pair. So this is not specific enough. Because I can give a counter example. The next one says a linear pair is a pair of adjacent angles. So adjacent, they're adjacent, which means they share a common side. And with non-common sides that are opposite rays. Okay, so this one and this one, the one they don't share, they're opposite rays. That would be a linear pair. If you add these together from here to here, and from here to here, it equals 180. So this is your best definition. And that's it for today. So here's your assignment, page 101 on 101, and the answers are here. But do the assignment first, and then, and as you're going, check the answers. Don't just write down the answers, because that won't help you learn. You have to think about these and reason through them. Let me know if you have questions. Thanks.